So at M7 Toker 7 has this question here in the comments on one of our latest videos. Asked, how did you determine the default gateways for the Palo Alto routes? Would AWS not default to the .1? And this again was in response to one of the videos within this Palo Alto series where we were demonstrating basic configurations, deployments, and using Global Protect. And so in today's video, we're going to actually answer this question here very shortly in a short answer. And then, of course, we're going to have a more longer answer for those that want to stick around. Demonstrate this, how it's functioning in a proper environment. We're going to remove those routes and see why it's not working. And then, of course, add them back to see that it is going to work again. So without further ado, let's quickly take a look at the environment. And so we have a basic Linux AWS instance running here. If we go to networking, there's 4 subnets. This one is in its own subnet, the server subnet, and then our Palo Alto firewalls, each of these being in the same VPC. It has the other 3 subnets, management, public, and private. Each of these has their own routing table, and this is to try to isolate and not cause any confusion there within. And so if we take a look quickly at that server, we're going to be working in the outbound direction, basically doing a ping from this server to the outside world. We click route table. We see that for any unknown destination, this is going to enter the ENI that's basically the private or the inside interface of the firewall. And just for grins and giggles, we'll just validate that to not try to shortchange anyone here. But that's to get that traffic basically moving in the outbound direction towards the internet and basically get it into the firewall for inspection and processing. And we see that this is indeed the private or inside interface. So the answer to that question, it's a yes and no, but it's really more of a no. So the no is AWS does not configure anything on the Palo Alto firewall or add anything there. There are API calls that are done to provide the Palo Alto firewall information. So it's kind of a yes partially because these are the 2 interfaces, outside, inside. And then if we click on this link, as long as the address is dynamically set, it'll retrieve these every so often. And so we see here that it does know about that default gateway for that subnet. And so we know that for each subnet in AWS, there's those reserved IP addresses. The first is going to be the network ID. The second IP address, this .1 here, is going to be the gateway. The third is going to be DNS. That's the .2. And then the fourth is reserved. And the last address with no broadcast being used, it's reserved as well. So if we click away, it's kind of a yes. It does provide those details. So the interface does know about that gateway or that .1 address. And if we come here to virtual routers, again, we did configure the 2 static routes. We'll leave them there, demonstrate that it's working, and remove them. And of course, so that, yeah, AWS doesn't put them there, or else it always would be working. But in the more runtime stats, if we click here, these first 2 routes here are the 2 static entries that we identified. Those are the ones that we'll be removing. And these last 4 are by default. So there is that local reachability on the subnet where, of course, it knows about the subnet's IP address. And there's that explicit route in the AWS route table. Let's not confuse the 2 that allows that reachability for host or NICs really on that same subnet. So it's kind of a yes there. And then the forwarding table really looks the same, but adds the next hop and identifies the interface to forward that traffic towards. So that's kind of the scene that we're set up here. I know it took a while to get there. And like I said, thanks for those that are still hanging in here. We'll use the iPad and, of course, do some drawing here shortly. But let's go back here to this Linux instance. We'll click here and then we'll hit connect. We'll use our VPC, our EC2 endpoint, just straight hit connect there. And all we're going to do here, probably in about 10 seconds, is just ping quad 8s. These will successfully go through. It's just demonstrating that in unison, the AWS route tables and the configuration there, the firewalls route table, and of course the routes there are working in unison correctly, along with allowing the security policy and the proper NAT rule there as well. So if we click here and we ping quad 8, we'll see that those requests, those ICMP echo and replies, the responses are coming back successfully. We'll keep it running. It won't hurt anything too much, really. But again, if we come back here now, and if we go to, or we'll stay right here, we'll go to default. This is the virtual router that we didn't rename it or anything. And we'll just remove these two routes here. We'll hit OK. And for the sake of everyone's time, we won't put a description, but we normally would. And we'll commit this change here. And we'll come back and sit in the console. And we'll look and see it will start hanging here shortly when that commit goes through. This is basically demonstrating or showing that there's, without us explicitly or manually putting in those routes, like there we go, traffic is going to be black hole. And it's really because as long as we had some use case where all we needed was for traffic to stay in the firewall, or if we put our servers in the same subnets as the firewall, which isn't highly advisable, and we didn't need to route towards the internet, another VPC, another subnet, then that communication would go. But for any production or even a lab environment, we know that we're going to have a different subnet or something like that. So when you need to get off the subnet of one of these two interfaces, that's where you really need to know the route to basically forward that traffic towards the interface, and of course that next hop IP address. So again, if we come back here, we should see that we were getting those pings. There we go. So if we filter, if we were to filter on this source and this, we would just see those flows there. But we see that that traffic's coming through. So again, if we quickly go back and then we, let's see, if we add it here real quickly, we'll see that again, without stopping the pings, that they will come back. So we'll hit add. We'll quickly put these two routes back in. DR. This is default route is what the DR stands for. This was the ETH11. That's going to be 10.0.1.1. Hit OK. This would be LAN. And this, again, these are lazy routes because it's a lab. It's not really really specific. It's especially with this big supernet here. But everything that's on the LAN or internal is going to need to come across this inside interface. No DMZs or any tunnels or anything like that. VPN traffic, etc. Forgot a dot. All right, there we go. So now we basically have added our two routes back. Let's see, what did we do? Oh, sorry. This should be 10.0.2.1. And that's that gateway address in AWS. So, and again, we're going to draw this out to make it more clear, to bring it home. But before we commit that, like we said, we removed those routes. So right now, the reason it's not working is because not only in the route table, like I said, we showed before, the two static that were above this, but when it's forwarding traffic in the outbound direction, it doesn't know how to reach 8.8.8.8. There is no route there. So this traffic is currently being black holed. It's coming into the route, the firewall's inside interface, and the firewall is going to just drop this traffic because there's no route. That's why we need to be explicit anywhere that we can. and not leave it to chance. But in this case, again, AWS does not add a route. Again, it provides details or information to the interface about the gateway so that the interface can, by default forward traffic. And then this is an extra nugget, not really here. So we'll commit this. Actually, we'll commit this, and then I'll quickly explain it. So because we're going to see the traffic coming through. But people wonder why, if I mess a route up, I don't have it. How can I still be in a session? It's because the data plane is separate from the management plane. We don't see that traffic. But if we go to device, quickly go to setup, and this profile for the management, this is why we can always still access this device, because our management session, if we were SSH'd in, is coming across here. So if we go back here quickly, these pings have started. The commit, of course, took place there. So in a nutshell, long explanation verbally, and then kind of in here to demonstrate kind of how that's working. But let's go to the drawing, and I'm gonna kind of show this to hopefully nail this home, because I've been personally, it's not about me, but been working with AWS and virtual firewalls, sometimes just native AWS. I've been in environments where there are no firewalls, no CSRs. It's just TGW transit gateway, some VPNs, and native AWS routing. But specifically here, we'll start with, if this was on-prem and we had like a Palo Alto firewall, and this isn't where the port placement is, but let's just say we had our port 1 here and port 2. That's not the name. But then we had our ISP device here, and we had a physical connection here that went there. And then, of course, let's say we had a connection here that went towards a downstream core router, core switch, whatever you want to call it. We'll say core switch instead of a router. Then the thing about this is all, like in totality, all of the routing is going to be contained on this device. Basically meaning that this device is authoritative. Maybe this is an I, but forgive my spelling. And that therein lies some of the confusion, because when it comes to AWS, we now have an issue where we have to walk the dog, is what I like to call it. And it's basically in the outbound direction. We'll go right to left. But what we have here is we have a subnet, because the firewall, really, in the perspective of AWS, it's just the NIC. It's a NIC that's in the subnet. And there's two things here. So we have that Linux host that has an interface, a NIC here, and it sits in this server subnet. And then it needs to reach, it has a route table that said for all unknown traffic, basically send it to the ENI of the firewall's inside interface. And so that's what it did. It says, I need to reach 8.8.8. That's my packet. So in AWS's route table, in this same subnet, like, let's send it towards the firewall. So now the firewall has 3 subnets, but this drawing's starting to get a little bit ugly. But we got a firewall that this traffic is coming in on the inside or the private interface. We'll just say private. And then again, now it's inside this virtual firewall. Now we need to consult this route table to say, how do we get here? And therein lies the quandary. When we remove those routes, it said that the destination, of course, is 8.8.8. And we saw that we only had the 2/24s for basically the interface here, and then that public interface. We only knew about those 2 slash. So that's why we needed to explicitly add the entry. And again, we just did a quad 0 that said to reach that, go to the .1 of that 10 address to get back on these subnets, which is going to be the publics. AWS route table. So we're bouncing back and forth between the firewall's route table and AWS's. But in this case, unlike being on-prem and having a physical device, the authoritative routing engine is really, it's AWS's route table. Like this again, these are just subnets that still ultimately need to go to that .1. And then to get to the internet, if we go back here, well, let me draw it real quick. When we need to get to the internet, we're going to see that we're going to point to the internet gateway. The firewall isn't pointing to the internet gateway. It's AWS's route table. And so if we come back here underneath subnets, if we click on the public and then we go to route table, we see there's an entry to, it's AWS that's ultimately determining and moving these packets along among their environment. So we have to know that there's just one box with multiple interfaces and in our case, one route table inside this firewall. But that box sits on AWS that has all these, we see each of these subnets has a route table. So we see that there's going to be ultimately 4 route tables. So it's the bigger construct. But long story short, we need to break it down and just understand where in the context does this lie. And it's ultimately in this environment or any AWS environment, it's the AWS route table that's going to be the authoritative source for getting traffic. So again, a long explanation, both in demonstration as well as in this little messy drawing, but I hope that kind of drove home that the easy answer would have been a no, AWS does not insert anything into the Palo's route table. I mean, it would be magic and a beautiful world, and maybe they'll get there one day, but I don't know if these proprietary companies with their products will permit that. Like I said, the power of APIs are pretty awesome. So there's ways to quote unquote automate, but that's not AWS that would be doing that. That would be kind of like middleman, middleware or something doing that and using the logic to perform that. But I digress. Again, want to thank you so much at M7 Toker 7 for basically giving us today's video, and for each and every one of you out there, especially those that watch this entire video. I know these are doozies and you got folks out there that just want a quick answer. But for those, again, like I said, that got value out of this video and continue to support the channel, much love, respect, and appreciation to you. But until next time, stay safe, take care of yourselves, and peace.